In this review of inference, we're going to first start by talking about populations and samples. So we're going to talk about a population, which would be the group of individuals that we're interested in. And if we find any numerical facts about that population, things like your mean, our standard deviation, things like that, mean, standard deviation, median, anything that you're going to calculate about your population would be called a parameter. So our parameters are facts about our population are usually unknown because we don't know the population in statistics, in most of what we do in statistics. So we want to know the value of the parameter, but we can't do that without knowing the data for the entire population. And so our main goal of statistics is to estimate the parameter. Anytime we're trying to do this to estimate something about the population, we're going to call that inference. So in our example, an investigator wants to know what percentage of voters in the US plan to vote Republican in the next election. So the population would be all the voters in the US. The parameter would be the percentage of all the US voters who plan to vote Republican in the next election. So we like to use that keyword all to remind ourselves that it is for all of these people. For our samples and statistics, typically it's not feasible to collect data from every individual in a given population because that's going to be too expensive or take too long. So instead of collecting data on everyone, we're just going to collect it for a smaller group from the population, a subset called the sample. So our sample is that smaller group we collect the data on. Our statistic is a value calculated from the sample. Again, that could be like your mean, your standard deviation, etc. We can calculate lots of things. Now we can use those statistics to estimate our population parameters. So we use our sample statistics to draw conclusions about our population parameters. So we call this statistical inference because we use the sample data to infer conclusions about the population. So an investigator wishes to know what percentage of voters in the US will vote Republican in the next election. Again, he takes a random sample of 1,000 voters throughout the US and finds that 44% plan to vote Republican. So the sample will be that 1,000 voters that he looked at in his sample. And the statistic will be the 44% in the sample that plan to vote Republican in the next election. So what is your best estimate of the population percentage of US voters that plan to vote Republican? So our best estimate for the population percentage would be the sample percentage. So our sample percentage of 44% is our best estimate. For the population percentage. Just a review of notation. So if you have your population parameters, your mean will be mu, but the mean for your sample will be x bar. Standard deviation for the population is sigma. For the sample, we call it s. For variance, we should have sigma squared. For the sample, it should be s squared. For your size, it should be n or n lowercase for the sample.